Excellent. Thank you very much for that, 𝗚𝘂𝘚. And I hope that music has got everyone happy and ready to dance. So let's dance with data. Thank you very much. So my name's 𝗕𝗿𝗄𝗯𝗴 and I work for a company called Delphix. We've partnered with Brightest to bring you this brown bag session. And what I want to do today, so my background, I've been working in IT since about 1986, and my first job was testing an admin system for a company called BUPA, the British United Provident Association. And so I spent many years in IT. I've done a number of tests. I've delivered a number of projects. Today I work for a company called Delphix, and I've been with Delphix for about 8 years now, just over 8 years. I joined Delphix from Oracle, and I used to run a pre-sales academy for Oracle down in Malaga. But I've spent a number of time delivering projects, and I wanted to just share some of my experience from way back when to now. You know, one of the reasons I'm still with Delphix is because it's a rock solid product, and it delivers some test data management capability that is used by a number of organizations around the globe. So that's me. Feel free to reach out to me. As 𝗚𝘂𝘚 said, we're going to take questions at the end, and I'm going to try and run through this in 30 minutes. So I'll need to talk quickly, and hopefully you'll enjoy this session, and it will bring some value to you. So let's set the scene in terms of where we are in the industry. So everybody's looking to go from slow to fast application releases. They're looking to achieve the sort of release schedule that the hyperscalers say they can do, and that's thousands of releases a day. Okay, so that means effectively we must test quicker. The other part of the world in which we live is that we're no longer operating in a single on-premises environment. And in fact, we're no longer operating in a single cloud environment. The imperative is that we need to be able to deliver our enterprise applications across multiple clouds. That provides some simplicity, some guarantees around the non-functional capability. But I've also seen in some cases that people are moving off of the cloud for various different reasons around control and the cost of that. But you know, most of the time we need to be operating in this multi-cloud environment. So that means we have to not only test quicker, but we need to do that in more places, and we need to operate across those places, arguably somewhat more interesting. And then the other part of that is the fact that we've gone from a kind of a high trust castle approach to a zero trust approach, providing data across these clouds. And obviously we've got privacy regulations coming into play. I don't know whether you know, but just last week, Saudi Arabia brought in its GDPR. That's going to get some teeth in about a year's time. But many countries are delivering those GDPR-like security regulations. But we also live in a dangerous world where we've got hostile nation states who want to get hold of your data, and also some ransomware gangs as well. So we've gone to high trust to zero trust. So that means we must not only test quicker in more places, but we've got to make sure we're not leaking sensitive production data. So that's the environment that we live in. But if you know any of you are testers out there, one of the big challenges that certainly I've seen for my career in IT is actually getting good data into the test environment, or as I put it, feeding the tester. And what you see is if you get good test data, then often you get a happy tester. And that's a little bit of a joke there, but what we see is even developers, as long as we feed them with the information that they need to do their jobs, then you get a higher morale in your organization and a happier workforce, arguably. The reality, of course, is, and certainly what I've seen, is that sometimes it can seem to take forever to actually get that test data in place. And a lot of the reasons for that is some of those things that I've described, the different places, but often we need to go through this chain of people in order to get a test environment available for us. We've got to go through the developer, the DBA, the management, storage admin, sysadmin, backup admin. Even if we're operating in the cloud, those environments can be difficult. And one of the things that's not mentioned here is network security. Often that's one of the biggest blocker, and often many of these actors don't seem to be able to communicate with each other in the right language. And that's where we look towards getting some kind of autonomy where we don't have to go through this approval chain or this delivery chain to get hold of that test data. I just want to talk about those challenges, right? So this was a project that I encountered a while back, and I actually trying to deliver Delphix into this environment, and we thought that it would be simple. But what they said was that their existing infrastructure was stretched. They didn't have any space. They didn't have any systems to give us. There were no environments to work in. Everything was being controlled by an outsourced infrastructure team. We, of course, tried to beg, borrow, and steal some infrastructure, but that was deemed as a security risk. And then at that point, we had to put some costs in place to get the infrastructure in place. Well, that required approvals, and believe it or not, that approval took 6 months. Once we got that, we got the environment built, but they provisioned the wrong operating system. Once we got that sorted out, we were re-provisioned, but because they had production issues, that delayed the project. Delaying the project by 2 weeks took us into the Easter holidays. That meant that staff was unavailable. Again, discussions ensued. Should we proceed? Shouldn't we proceed? We decided to proceed with limited staff, but then they set the environment up wrongly, and then there were other production issues, and we were actually in the middle of the project requested not to go on site. We actually ignored that request, showed up on site anyway, but once we got on site, we were unable to connect to production. There were further approvals required. The infrastructure that they provided didn't meet the requirements. There was a no exclusive use of the target environment where we were doing this testing. And in actual fact, because the project had slipped, that had knock-on effects in that they were testing month-end in that test environment, and we managed to crash their month-end testing. And we were requested after that, quite strongly requested, not to touch that pre-production environment, and our testing was halted. We then got back on. They provisioned the wrong version of the Oracle database. We ended up sorting that thing out. They also said that we had to wait for a masking job to complete. That job was supposedly took 24 hours. In actual fact, the SLA with another outsourced provider was 24 hours, and the job actually took 3 minutes to run. By the time we got all this in place, they then said that key personnel were unavailable for testing. They were either testing other things or they were on holiday. And then they said, well, the database version no longer matches the application version that we're trying to test against. Long scenario, long story, but I'm sure that anyone in the test and development world has met those challenges. So moving on then, if we look at that, we've got all of those challenges, but on top of that, we've got the challenge of complex data. And often it's quite difficult to explain, why is data complex? How does it become so complex? And I've taken a look at this over time, and often if you just boil it down, a lot of these applications, particularly legacy applications, have been around for some time. Often requirements and systems change over time, just as language changes over time. Data structures get modified. Fields in databases become redundant. Either that they become redundant or they get reused, repurposed, reformatted. Systems get added. Integration gets added. Other systems are using those reused, repurposed fields. Often the business only understands the application based on the graphical user representation of that data. And that is often quite different from the data format that's held in the database. And therefore, getting someone to understand the data is a challenge simply because of that. There's a mismatch between what the business sees and what the technician sees. And obviously, data formats can be different in different systems. Values get duplicated for efficiency. They get normalized as well. It's hard to understand which is the source of truth of the same data values. Obviously, within a business and within government organizations, rules change over time. The rules actually differ between different jurisdictions. They differ actually even between different departments. And data tends to be rather fluid as the development process progresses. And the form factors and representations of that data change. And then obviously, I worked on a big government system, a pension system, and that was a crazy world where regulations changed on a yearly basis, but we still held historical information over the lifetime of a human, or the working lifetime of a human. And therefore, all of that historical data needs to be maintained, it needs to be managed, and it needs to be accounted for, even in later, newer systems that get delivered. And finally, developers tend, I was a developer once, so I know, we tend to do weird and wonderful things to manage around the data and the restrictions that are imposed by data. I've even seen where a piece of data has actually crashed an Oracle database, and the team has actually coded around that to actually ignore that single record. So with all of that in mind, I think the main thing is that agility is key. We have to be quite agile, and we have to get hold of the data and be able to deliver that data down to the practitioners and the experts that can make sense of it. So that's the data world, but we've come a long way, right? So if you look at, test data tooling and getting the data you need, we've got these tools around server virtualization. So we've got, the advent of VMware, Hyper-V, the KVM hypervisors. These all allow us to provision operating systems very, very quickly. And obviously, with the advent of the private and public clouds, getting hold of a virtual machine or an operating system is a fairly trivial process. That can happen quite quickly. It might be expensive, but it tends to be easy to do. The other thing we've got around test data tooling is around storage virtualization. So if you look today, a lot of the storage vendors have storage that is software defined. It can be virtualized. We have flash clones. A good example is Dell PowerFlex. We happen to partner with Dell, and I was looking at that system, which allows you to provision, compute and or storage, allowing you to shape your infrastructure as you need it and provision it as required. There's also the piece of data virtualization, which we're going to talk about. We're going to talk about Delphix, and our data virtualization is a specific kind of virtualization at the storage level. There are other types of virtualization, which I describe generally as federation. So our data virtualization is actually the virtualization of the storage. In production, you do get virtualization with companies like Denodo, who actually virtualize in a network layer. So they actually create a layer above the actual databases that you look at. So that's slightly different from the data virtualization that I'm going to talk about here. Obviously, another tool is synthetic data generation. You can't live without that. If you ask ChatGPT, that does some wonderful things. You can create data very quickly. There are many, many tools out there, both free and paid, that provide facilities for you to generate data, web-based tools and actual tools that you can download and use. There are many, many options out there. I won't list them all here today. The other piece, of course, that we need when we're doing testing is the ability to subset that data or get sets of that data. Again, there are free and paid for tools out there, like Jail is one of them, dbeaver, Toad, or your favorite SQL tool will allow you to subset data. Obviously, if you're running a very large application, subsetting data is a very, very challenging task that even the application vendors themselves struggle to actually achieve. And the best way to achieve that is to be able to iteratively go round and look at what data bases you actually need in order to do the subsetting across an application. The other piece of work that we do around testing is obviously service virtualization. Here, where you create a mock API call that gives you a dummy response. And that dummy response can be quite intelligent, but to provide an intelligent response, you generally still need data, and that data needs to be delivered in a certain way. You either need to code it, or you need to point to database systems to give you that data. And the issue around service virtualization that I've found is that if it breaks, it can be quite challenging to understand whether there's a problem with your application or a problem with that service virtualization layer. And then one of the interesting things I've noticed recently is around digital twins. I was looking at a government testing piece around an insurance company, and they let me know that Norway actually has a digital twin. That is, there's a whole Norway out there with real people giving birth, people taxing things, buying cars, and that is a complete digital twin of the government data that resides in Norway. I've also seen this in the car industry, where we're creating digital twins of actual cars so that they can actually do testing against that digital twin. So that's all of the test data tooling. The issue with all of that, of course, is that you need someone or some people, a team of people who understand all of that and can bring all of that together to deliver your testing environments and your testing capability. And it's a complex scenario. So if you look at how testing then develops, there are a number of arguments and a number of different components in terms of getting quality data and getting speed and accessibility of that data. And if you look at this graph here, a good way of getting quick data is to synthesize that data or to create data subsets. You can iterate quickly through your unit testing before you go on to do full testing in either shared data environments, where you're using data, sharing data between people. That makes it, reasonably good access, but the quality of data in shared environments tends to be an issue. You tend to get stealing of people's data. You just prepare an environment in the application, you go to use that data, and someone else has either changed that data or use that data for other purposes, and you have to go back to the beginning. So that leads to contention in the test environment. And also the other idea, if you get full production clones of data, that's great quality, but that tends to be difficult to achieve, and then you get the requirement to actually mask that data and protect that data, and there's a lot of infrastructure requirement also for those full production clones. One of the big issues around that often is that data isn't refreshed. So that's accessing data. The other idea now is this virtualization of data, and obviously that's useful in its own right. But what we tend to do is, if you take all of those components around full production, data subsets, synthetic data, and shared environments, if you drop those onto a virtualized environment, then you get data quality and data speed. So changing gears now, if we look at what Delphix provides for you in its data virtualization, the thing that we need to do there is in actual fact, we bring all of that data from the production environment, hold it inside this data virtualization layer, which then provides a rolling live archive of that production data. So we automatically sync that data into the Delphix engine, we shrink it down by about a third of its size, and we automate this rolling live archive of data. And from there, we have the ability to provision a virtualized copy of that data. And the way that we do that is by providing a mount point onto the target database servers and giving you a access to a file pointer. The data doesn't move, but we share a pointer to those blocks of data. So in that way, we can create this data very, very quickly. So, recently I was looking at a 4 terabyte database. Took us 5 hours to get that data into Delphix, and that's how long it took them to copy that data. Within Delphix, we were provisioning a copy of that in 2 minutes, rewinding it in 2 minutes, and creating a backup of it in 19 seconds. More recently, I was working on an Oracle 20 terabyte Exadata database, and that took 55 hours to copy into a traditional manner, but we were able to copy that data in a virtual sense in just 55 seconds. So that provides a base capability of getting the data available to you very, very quickly. But then within that, we could then put those sets of data into what we call a data sandbox effectively. So if you've got an end-to-end test that requires 3, 4, 5 more application databases, we can put all of those virtual databases into a container or into an environment where we can tag those, and then we can operate on those databases with a single operation. So if you want to bookmark or back up that set of data, that test environment, that can be done with one API call, one click of a button in the self-service interface to provide a rewind capability for those virtual databases. The other piece that is quite interesting is the ability to take that data and put it anywhere you like. So synchronize that data from a production data to a non-production data center, from one data center in one part of your organization to another data center, or indeed to any one of the hybrid clouds, so that we can actually replicate that data incrementally and allow you to have these non-production sandboxes replicated in any of the cloud environments or in all of your cloud environments. And that gives you the ability to run your test environments anywhere that you like and keep them synchronized with your production sources. So that's virtualization and the ability to actually move that data around, create a copy of the data quickly, have a self-service interface to provide access to that data. But one of the other, elephants in the room is masking that data, and there are a lot of tools out there to do masking, and often either the application or the database provider will give you masking capabilities, but that tends to break the end-to-end testing capability. So really you need a masking or an obfuscation tool that will operate on all of your data sources, be that on premise or in the cloud. So as I said, as you see here, if you use the various different masking tools, then that will break that end-to-end capability. So what you need is a unified set of compliance requirements that's comprehensive, so you can discover and mask everything wherever your data resides. It has to be consistent so that you mask it in the same way to give you that determinism to provide referential integrity, not only within the database, but across your enterprise and across databases. You need to be able to mask with realistic values. It's no good, obfuscating it with a hash value that doesn't represent real values that you can use to test. And then also you need to be able to take the data that you have masked and clone that anywhere, so you're not constantly waiting for data to be masked in that test environment. And that needs to be done automatically. I'll share these slides with you, but if you look at those compliance requirements around discovering and governing, comprehensiveness, consistency, the ability to be usable and virtualized, there's some reasons here on this slide that show you why that's important and how that can be achieved. And once you get that unified data masking, that allows for you to do end-to-end testing. So then how do we then take that and then automate that in a world where we're able to provision ephemeral environments that we can stand up and tear down in the cloud, in any one of the clouds, in on-premise environments? What do we need to do that? Well, we describe here the fact that the operations need to be API driven. You need to be able to access all sources and all clouds. You've got to put that data compliance piece, that data protection masking piece in place. You have to be able to version control that data so that you can be operating on different projects which have different timelines. The data needs to be immutable so you can restore back to a point in time. The data's got to have utility, so you've got to mask it in the right way. And also, because you need lots of copies of that data, it needs to be space efficient. You've got to get a handle on costs, particularly if you're delivering that data out into the cloud. So how does Delphix do that? Well, we have this self-service interface that allows you to, as an end user, to press a button to refresh that data from the latest version that you've got in production, and that latest version may already be masked with a self-service masking capability. We have the ability in that self-service control to bookmark and then rewind to a bookmark. So that allows you to actually, as an end user, create a restore point, do whatever test you want to do to destruction, if you like, and then rewind back to that bookmark point. And then also an impressive ability to be able to branch that data. So because we're sharing file pointers, we're able to create a copy of those file pointers and create a whole new database set of data on the same connection string. And that allows you another layer of capability, another layer of effective databases in which you can do iterative testing or testing across different sets of data. And so if you look at taking that capability and then automating that from an API perspective, we're able to create those databases and then create multiple copies of those databases or create branches of those databases and run through iterative tests, putting those databases also into self-service containers and providing those containers for end users to do those testing. And those end users can either be humans or they can be machines. And if you look at the more detailed, we could take one of those virtual databases and create bookmarks as we iterate through those testing. So if we look at some of our largest customers, do this kind of iterated approach, and so that if a test breaks at some point in that test case cycle, you can restore back and just iterate one of those tests rather than going back to the beginning, restoring your database and starting again. And that brings untold value in terms of being able to run through your iterative tests quickly. Another key point before I finish is that within the virtual databases, you've got another layer of automation. So that layer of automation really allows you to provide a kind of an orchestration of the database. So before you refresh a database, it may be that you want to shut down the application. You may want to run that subsetting. You may want to run masking and do certain actions before you actually operate on those databases. So not only do we have an API that will allow you to deliver the database just in minutes into that CI/CD pipeline, but we've also got a hook point which allows you to control what's happening with those databases within that virtual database lifecycle. This is quite a busy slide, but those hook points where we can apply scripts allow you to, in that, creating a refresh point. Before you refresh, we can run a pre-refresh operation. We can, in the configuration clone, do some work on that database after you've refreshed it. And then in the post-refresh, we can do some actions like, start the application, that sort of thing. And that needs to operate against multiple different database types. So what that does, that allows your CI/CD pipeline to have a single API point regardless of the database type, whether it's a Oracle SQL Server or any of the NoSQL databases or a cloud database. And with that single API, you can call any type of data to put into that, plug into your pipeline. That's me. That's what I wanted to talk about. I think we can open it up now to questions and answers. We've got just a few minutes left. I've kept within the 30-minute time. If you are interested, my details are on these slides here. I've provided some links which 𝘕𝘂𝘚 will share this slide deck, and you can look at some of the examples of how our customers have used data virtualization and data masking to provide value in their organizations. But let's open it up for questions now. Thanks, 𝘕𝘂𝘚. Have you got any questions?
Yeah, I do, and maybe because I saw in the session that a few of our bright test automation minds are in the session. How easy is it to implement some workflows of Delphix into a test automation project? It's all API based. Is it completely technology agnostic? Do you have a dedicated space where they can find information about that? And yeah, what would be the type of return on investment you have when you implement it in conjunction with a good test automation strategy? I think that multiple question in one, but sorry.
Yeah. So how easy is it? Well, we have a REST API. But often with REST APIs, they can be a little bit complex, right? So if you're not a developer operating at the API level, maybe you're just a DBA, then often you need a wrapper layer around that. And we do provide a wrapper layer. So we've got an open source toolkit called DX Toolkit, which provides a wrapper around that, so that then you get a command line that says, refresh the virtual database, create a virtual database. So quite simple single line operations, and that's quite easy to implement in whatever tooling you're using, whether that's Jenkins or Azure DevOps. So that piece is relatively straightforward, or trivially straightforward, to be honest. You can actually do that work. So anything that you can do within our user interface, our self-service interface, you can also do within the API, and we've got a wrapper around that. And that wrapper's been around for a number of years, so it's pretty robust and pretty comprehensive on what you can do. On top of that, we do have a command line interface. You can use the command line, but we also have what we call that data control tower, that bottom piece there. And that's not only an API gateway, but we also a provider for other tooling. So we're a Terraform provider, for instance, which simplifies the operation of doing that automation. In terms of the return on investment, we do have a document that was created by IDC that looked at our 10 top customers, and they came up with some ridiculous figures around the value that Delphix can provide. Now, if you look at even just looking at the storage savings alone, when we provision a virtual copy of a 10 terabyte database, that might only be just a few gigabytes. It tends to grow over time until you refresh that virtual database. But that, if you've got an environment where you've got a large database, let's say 10 terabytes, and you've got 5, 6, 10 copies of that, then we can reduce that down to about 10 or 20% of that volume. And that's a significant saving in terms of storage. Obviously, if you've already got the storage there today, you're not going to see that saving specifically. But if you are moving to the cloud, then that is significant, very, very significant. On top of that, quite recently, we've brought out a caching layer within the cloud, within AWS and Azure and GCP. And actually, if you're using things that blob storage on premise, we can actually take 50%, 75% of your storage, which would normally be running on SSDs, and we can run that on S3 buckets or Azure blob storage, and that is a fraction of the price, and you only pay for what you use. So there's significant ROI savings on the storage, but the other savings are around developer and tester wait time, right? And if you've got a large organization where you've got more than 5, 10, 20, 100 developers, then that time saving, just saving an hour a day, is very, very significant. And that tends to become larger than the actual physical infrastructure savings. But yeah, it's huge. The state saving is very, very significant.
Okay, thank you, Gary.
Thank you.